Well, hello, scrappers. Mike here. Welcome back to my channel. And once again, I have my incineration set up out here. We're going to incinerate some stuff today, or at least we're going to try to. We're going to answer a question that I have had for a while now about whether incineration is really the best way to approach some things. And I don't think it is. I got a friend, Ken, up in BC, Canada, and a while back, quite a while back now, he sent me a whole bunch of stuff. And he's like, Mike, all you got to do is pyrolyze or incinerate this stuff, separate out the gold plating, and it's happy days. Well, I got a machinist friend who hates conversations and start with all you got to do, because usually the people who are on the other end of that conversation are asking the impossible or the incredibly difficult, or don't realize the magnitude of what they're asking. And well, I tried some small scale tests, and I will repeat these on camera because these tests I did were off camera. I'll repeat these on camera, and I'll show you exactly why I don't think incineration is the right answer for some things. First, though, let's go take a look at some of the stuff Ken sent me that he thought could just be incinerated or pyrolyzed, and then we're good to go to get the gold out of it. So let's go take a look. Okay, I've had to back the camera up quite a ways to try and get all this stuff in. So Ken sent me all this stuff a while back. I'll put a link to the video where I unpacked all this stuff he sent me. Just bags and bags and bags full of stuff from his depopulating of boards. And he sent me, a lot of this stuff was packed inside it, and this was in a big box with other stuff packed around it. This big steel chamber with a lid. He's put a label on it, Pyrolyzer 6000. And you say, Mike, just put these in there, punch some holes in it, make a fire, pyrolyze all this stuff, and you're good to go. All right? Well, it's not a bad thought, but for some of this stuff, it's just not going to work. All right? Yeah. I mean, look, here we got some circuit boards. What these are the touch pads, mouse pads from laptops and stuff. Well, they're basically built on circuit board material, which is glass reinforced plastic. And, well, anything with reinforced with glass doesn't work, and I'll show you why later, okay? So we can't really incinerate or pyrolyze these, okay? What do we got in here? Well, we've got a lot of SATA. We got a lot of SATA headers off of hard drives and stuff. And guess what? It's glass reinforced plastic. So we're going to have problems with this stuff too, I'm thinking. Okay. What we got in here? Well, it's the headers off of, well, I don't know what they're from, all of them. I mean, some of them are from parallel ATA hard drives, and some are from something else, maybe SCSI drives. They still have board sections attached to them, which is going to be a problem. But again, these are mostly glass reinforced plastic. We'll talk more about glass reinforced plastic later, what it is, and I'll show you why it's a problem. We got in here, we got edge card connectors. Yeah, that looks like part of a RAM stick connector. Yeah, some sort of D-shell connector. More RAM stick connector pieces. Well, there's a lot of gold on that. I don't know if it's showing up shiny. This looks like maybe from SD card connector. Centronics port connector. Now, I'm looking through this stuff, and most of it, well, there's another SATA connector. Most of it has the look of glass reinforced plastic. Some of it may not be, but the vast majority of it has the look of glass reinforced plastic. All right. What do we got over here? Well, we've got Pentium class processor sockets. Maybe some Xeon class processor sockets. Oh, and here's some older, like 386, 486, or the early Pentium sockets where they still had pins. Okay, and these all have like hundreds of little gold-plated fingers in them to engage with the balls on the bottom of the sockets or the pins on the bottom of the sockets, depending. Glass reinforced plastic, unfortunately. Little tiny, tiny, tiny dual inline connectors. I see lots of gold plating on them. Again, they have the look of glass reinforced plastic. Over here we got headers. Headers, headers, headers. Headers, 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 lots of headers. Now, there's a whole lot less plastic here, and it may or may not be glass reinforced. These might actually be good candidates for incineration or pyrolysis. I don't know. I guess we'll find out here in a little bit. What do we got here? These are the connectors for the motors on hard drives and the feed-throughs for the data for the read-write heads on hard drives. Ken's obviously been depopulating a lot of hard drives. That has the look of glass reinforced plastic. These little arms that hold the power connectors for the motors. And these kind of look like glass reinforced plastic too. Though there's a lot less plastic here than in some things, so maybe it won't be such a problem. And what do we got over here? Some sort of connector. I don't know what it's from. Ken didn't tell me. No idea. I see a lot of gold plating on the legs of it, but it has the look of glass reinforced plastic. Okay. So I'll give you a close-up look at some of these things, because I know the camera's pretty far away trying to get all this in. I'll give you a close-up look at some of these things. Alright, so here's closer-up looks at the stuff I'm talking about. Here's the headers, which really don't have that much plastic attached to them, and I can't really tell just looking at it whether it looks like it's glass reinforced or not. Over here, we've got Ken's mystery connectors. I don't know what they're for. Lots of gold plating on them, but it's got the look, seriously got the look of glass reinforced plastic. Here's the hard drive hardware over here. And again, it has the look. Over here are the CPU sockets. And yeah, glass reinforced plastic again. Over here, we've got like edge card connector, D-shell connector, IDE connector. I don't even know what kind of connector that is, but they all, maybe not this one, but the rest of them all have the look of glass reinforced plastic. Over here are the PATA connectors and other type connectors, still attached to some pieces of circuit board. Well, we know the circuit board's glass reinforced, and the connectors have the look of glass reinforced plastic too. Over here are the SATA connectors. These have been pulled off the circuit boards, but these definitely still have the look of glass reinforced plastic. And of course, over here we've got the touch pads from laptops, and these are definitely, since they're built on circuit boards, they are glass reinforced. Okay, so what is glass reinforced? I keep saying this. What does it mean? Okay, well, you've got kind of plastic here. And to be perfectly honest, I'm not sure what kind of plastic it is, and I kind of doubt they're all made from the same kind of plastic. There's probably different formulations here for different things. But what they have done is they have mixed fibers of fiberglass, which is basically glass fibers, very fine glass fibers. They've mixed it in with the plastic and molded it into whatever shape they needed. And why do they do that, you ask? Well, it makes the plastic a whole lot stronger. All those glass fibers in here act like the reinforcing steel rebar in concrete. They hold the plastic together and prevent it from cracking and chipping as easily. just like the reinforcing bars in concrete prevent it from cracking and chipping so easily. Okay? So that's why they do it. Why is that a problem? Why can't we just incinerate this stuff? Well, I guess I'll have to demonstrate it and show you why incinerating it really doesn't get you anywhere. So let's go back over and we'll put some of this stuff in the pot there. We'll fire up the weed burner and incinerate some of this stuff and see what happens. All right, I've got some stuff in the pan here. I've got some of the CPU sockets, some of the edge card connectors, D-shell, whatnot. Some of the hard drive hardware down here, and some of the headers, which I think are the most likely thing to actually incinerate nicely. So we'll see. So I'll zoom out a little bit, and we'll get this thing going and actually cook some of this stuff and see what happens. Now you can see some of it's melting right away. I'll zoom in again. Some of it's melting, some of it's burning. Some of it not so much. Some of it just sitting there kind of. See how some of these over here really aren't changing shape. We're burning the plastic off, but the shape really isn't changing. These over here, they've sagged and melted. But they're starting to actually expand, like, I don't know, puffed corn or something as they heat up. Yeah, look how big the hard drive stuff's got. It's just expanded as it's burned off. The headers too. There was very little plastic there, but wow, look at how huge that mass is now. So I'm gonna let this go for a while. There's obviously still some plastic there that's in the process of burning off. But as you can see, even after we burn the plastic off, there's a whole lot of something here. And it's expanded. It's like we've got more than we started with. But we'll just let this go until we don't see any more flames coming off of it. And I think we burned all the plastic off. That'll take a few minutes. I'll turn it. Don't want to mix up my different piles there. Let it go. Alright. We'll just let this go. Be back in a couple minutes when I think it's done. Well, it's been a couple more minutes and this is looking pretty done. I still see a little flame coming off of this, so maybe we'll let that cook for another couple minutes or a minute or so. I say that, the flame goes out, so I'd say we're probably done. So I'm going to turn the heat off. And we're going to let this stuff cool down a little bit. And then we're going to look at what we've created here. Alright. Alright, this stuff's had a chance to cool down. So what have I created here other than a god-awful mess? You would think these ashes would be nice and soft and easy to break up. No, Even with a hammer, this stuff doesn't want to break up very well. This stuff over here, that's breaking up pretty well. This stuff over here, yeah, it's breaking up pretty well. But this is the stuff with the least plastic in it. So yeah, I'm seeing the pins being liberated out of it. Got this hard drive stuff over here. And it takes a little more effort. But yeah, it's breaking up. But this over here, I told you I've done this off camera. These Pentium CPU sockets, no. I mean, even hitting this with a hammer, they don't want to break up. I've tried putting them in my ball mill, and they have to be in there for an extraordinarily long length of time. But that will eventually break them up, if I manage to break them into smaller pieces first with a hammer. In fact, most of this stuff really needs to go through a ball mill to free up the pins from the ashes. So why are the ashes behaving like this? Well, it's the glass that was used to reinforce the plastic. Okay, we're burning off the plastic in the fire. Okay, we're creating an ash. Fine, that's okay. Ash is light and fluffy, right? But then the glass that's present as reinforcing in the plastic melts. And I think what's happening is, as the glass reinforcing in the plastic melts, it wicks out into the ash. Okay, and the ash then hardens up like rock from the glass that's wicked into it. I mean, you saw I burned all the plastic out of this stuff. It's basically just ash and metal, but there's glass in there, and the glass has hardened up and turned this basically into an ashy rock now, which even with a hammer, you'd be hard-pressed to break it up and free the pins out of it. Now this other stuff, yeah, it's finally breaking up, although I have had a lot of trouble off camera with a lot of the edge card connectors. The one I included in here did burn up pretty nice and is breaking up nicely now. The hard drive stuff, yeah, this stuff, some of it needs to go through ball mill or something. But here's the thing. Why should I incinerate this stuff and then run it through a ball mill and then separate out the metal? Why not just run all this stuff through some sort of an impact mill while it's still in the form of plastic and then separate the plastic and the metal, rather than trying to separate the ashes and the metal?
So I'm recording a little bit of a voiceover here because something started interfering with my lapel mic and it became all scratchy and staticky for a while. But anyway, I was going to talk about how the Mighty Mill has figured very prominently in previous videos of mine where I was on a small scale, testing-wise, taking connectors and things and crushing them up with the Mighty Mill and then trying to separate out the metal with various methods. Now, I think there's lots of other types of mills and crushers out there on the market that could do this job, could do it a lot better than the Mighty Mill can, because it's really not a production machine and it can't handle big stuff. It's got a very small grizzly up at the top to keep you from overloading it. But yeah, I think just cutting out the incineration step and going straight to milling the plastic and then separating the metal and the plastic is probably a better way to go.
It's really meant for ore sampling, and I've used it out in the field for ore sampling too at old mines. In fact, I'll put another link in the upper right to where I'm using it out in the field to sample ore I've collected at old mines. But, you know, something like this, an impact mill, I think, you know, on a larger scale, something maybe like Jason at MBMM has, where you could put the big edge card connectors in it, the big RAM stick sockets, all those SATA and PATA sockets, even the ones that still have the boards attached, you know, and put them through there, and then, you know, he can run it across his shaker table, and the metal will go one way, and the plastic goes the other, And I think that would be the best way to go. Because really, doing it this way, I've still got the issue of having to run it through some kind of mill to pulverize this stuff and completely free up. And see, there's a hard lump right there that's got, gold-plated pins sticking out of it. So I still got to run it through some kind of mill to free this up. We might as well just cut out the middleman of incineration, I'm thinking, and go straight to the mill and then separation. And the separation really is the hard part, I'm thinking. Crushing the stuff up, well, there's any number of ways to do that. I just don't think incineration gets us anywhere with this kind of material. Yeah, it works good with IC chips, and you've seen me incinerate IC chips any number of times in my videos. It's an integral step in the process that I use for processing plastic IC chips, and well, I'll put a link to one of those videos in the upper right. You can check that out. It works great. But there's still no glass reinforcing in the packages of plastic IC chips, so I don't have to worry about that. It just all turns to ash and falls apart nicely, like one would hope this stuff would do, but it doesn't. It doesn't. It needs another crushing process after incineration, and I think that's just too much work. Let me know what you think. Let me know if you've got any bright ideas out there on how to process this stuff. I'm really thinking impact mill and then separation, and then, plastic off to recycling, metal off to processing. How to get the gold out of that metal? Well, whether you incinerate it or just crush it up with a mill first, either way, you've still got the problem of how to get the gold out of here. That's a completely separate issue. But first, we've got to separate the metal from all this. So what's the best way in your mind? Incineration or just going straight to an impact mill? Leave a comment. Let me know what you think. Share any ideas you might have. Because, well, I've got a lot more stuff than just what Ken sent me. And I've got a bunch of boards in the back I need to depopulate. And I'm going to have another mountain of stuff. So don't be shy about leaving me any good ideas you might have. It'll make my life easier. And maybe we can improve the entire process of e-waste recycling, if we come up with something good and put it out there for everybody to see. All right. Well, thanks a lot for watching this video. I hope you found it interesting, educational, informative, inspirational, whatever. Give it a like, give it a thumbs up, and subscribe to see my future videos. And check out my other two channels, Electro Geek 64, where I've got all of my electronics and retro computing stuff. Not all of the electronics I get are recycled this way. Some of them are recycled into new retro computing projects. So check that out. And my other channel, Mike's Lapidary & Fossils, where all of my rock hounding, rock tumbling, rock cutting and polishing, fossil hunting videos, that's the home for them. So check those out. Please like, subscribe, comment there. And I'll see you in the next video. Thanks a lot for watching this one. Bye.